So what we just represented here were a few simple circuit diagrams. And now I want to get into the good stuff. But before I can do that, I should really introduce you to one of the most important things you will learn in this unit, and that is Ohm's law. So we began to discuss what affects the amount of current in a circuit. We began to discuss what affects the amount of current in a circuit. I should first remind you of what current actually is. Current is simply the flow of charge. So how can we get more of this charge flowing through our circuit? So in order to draw more current from our circuit, we can provide a greater amount of voltage. So someone had mentioned this in class, greater amount of voltage. And this is logical because voltage is electrical pressure. So one of the things we can do is we can increase the voltage. So in summary, 1, increase voltage. And what is the other thing we can do? Well, if we make sure that we minimize the amount of resistance in our circuit, then we will get current flowing through that circuit much faster. In other words, we'll have a greater amount of current. Or we can minimize the resistance in a circuit. Because again, resistance is anything that provides an obstruction to the flow of that current. So to increase current, we can increase the voltage, or we can minimize the resistance. R. Well, the relationship between these three variables, between current, voltage, and resistance, are defined by Ohm's law. And Ohm's law states that the resistance is equal to the voltage over the current, where R is resistance. We measure resistance in ohms. Let me make more space. The resistance is measured in ohms, where V is our voltage, which we already know is measured in volts, and I is the current, which we know is measured in amperes. So this formula is going to be crucial to us. Well, let's look a little bit closer at this formula. So let's bring it down here. So R equals V over I, in other words, Ohm's law. Well, I want to rearrange it. So I'm going to go like this, V equals IR. But then I'm going to go even further and say that I is equal to V over R. Now let's revisit what we were just talking about. Well, if I want to maximize the amount of current in this circuit, I can either increase the voltage or I can decrease the resistance, or I can do both. Okay, so that relationship is inherent in this equation. So we're actually going to use this information a lot moving forward. Okay, so another way that you can look at this. So let's look at Ohm's law through another lens. So let's revisit the equation in its original format. R equals V over I. Let's assume a constant voltage. So let's assume a constant voltage. Okay. Well, let's assume a constant voltage, so this number isn't going to change. Then what would be the relationship between resistance and the current? Well, if I increase the resistance under a constant voltage, then what will happen to the current? It is going to decrease. Okay, this is crucial. So under a constant voltage, if the resistance in a circuit is increased, the current will decrease. Okay. So anything that follows this relationship that we've seen right here is defined as an ohmic resistor, or an ohmic, just as an ohmic resistor. Okay, so I want to look at it through one more lens. So finally, let's look at this formula through one last lens. So R equals V over I. Well, I'm going to rearrange it back to V equals IR, which you might find to be the most preferable format to use this in, since it's probably most easy for you to manipulate. But now we're going to assume a constant resistance. So let's assume a constant resistance. Let's assume a constant resistance in our circuit. Now, if I keep the resistance in the circuit the same, what would happen if I increase the voltage to the current? What do you think is going to happen here? So if the resistance is kept constant, if voltage is doubled, then current is also going to double. Okay, so there is a direct relationship between the two. So assuming a constant resistance, we can say that resistance, we can say that as voltage increases, the current in the circuit will also increase. And this is pretty intuitive. These are directly proportional. Remember that symbol means proportional. So I can actually graph that. We can do voltage versus current, show a direct relationship here. And this graph represents an ohmic resistor. So this graph represents an ohmic resistor. So an ohmic resistor will follow this law, this direct relationship between voltage and current. There are non-ohmic resistors as well. Something that might be non-ohmic might be something that heats up a lot when you run current through it. We won't deal with non-ohmic resistors here. By the way, what is the slope of this graph going to represent? So what? I want to fix this. So what does the slope of this graph represent? Well, we know how we determine what's the slope. We're going to take our y-axis and do delta y over delta x, right? Slope is equal to delta y over delta x, which in this case is going to be change in voltage over change in current. What does that look like? It looks a lot like Ohm's law. So the slope of this graph is actually equal to the resistance. That's not a factorial symbol. Sorry, let me get rid of that so you don't get confused. So slope of this graph represents resistance. Okay. Now that we've kind of laid out some of the really crucial background information, I think we can move forward. So there is a really nice analogy that I just want to put out there for you.